Hi, my name is G.V.S Lohit and I'm making this video so that I can tell you guys about the new project which I have made. The project which I have made is a part of a fire IoT combo course which I have enrolled in Skyfi Labs, and the first of which is called the Smart Irrigation System, which I have presently made, and the motto behind which is that the sensor which I have embedded will detect the moisture sensor and water the plant according to the moisture level of the soil. So without wasting any more time, let's jump into my project and see how it works. So let's first go through what I'm basically aiming to do in my project. The basic aim behind what I want to do in this project is to sense the amount of moisture level which the soil contains, and if the amount of moisture level of the soil is below a particular threshold, then I want my water pump to pump the water into the soil so that the plant can get watered. Now again, after the watering, I want the pump to shut down if the moisture level of the soil goes above a particular threshold. Therefore, we need a sensor which can sense the amount of moisture level and give us particular inputs so that we can fix our threshold and use our pump or calibrate a pump according to the readings which the sensors gives us. So the basic equipment which I'm going to use in my Arduino project is an Arduino board which has an Atmega 328 microcontroller embedded in it. This is the Arduino board. I would like to tell that I have already connected all my equipments to the Arduino board. So moving on, I also need a soil sensor. This is basically the soil sensor, and this is basically the soil sensor module which I'm going to use. Also, I need an ESP8266 Wi-Fi module. The ESP8266 Wi-Fi module is used to send commands to the ThinkSpeak account so that we can analyze our inputs and know as to what our sensors and pump is doing. So this is basically a very important component if our project needs to be an IoT based project. Next, I also need a water pump which operates within the voltage of 6 to 9 volts. This is basically my water pump which operates between 6 to 9 volts. And also, to power my water pump, I require a motor driver board. So this is basically my motor driver board. Now, why do I require my motor driver board? The motor driver board is required because our Arduino Uno board cannot give the amount of sufficient voltage which is required to power my pump. So I connect my Arduino Uno to the motor driver so that my pump can get sufficient amount of power to function. Now, also I need a battery connector so that I need a battery connector. This battery is basically a 9 volts battery, and this is basically required to power my Arduino board and also power my motor driver board. And also I require male and female pin connectors. Now moving on, let's look at how my moisture sensor works, or basically how my moisture is sensed. So the module here is a YL69 probe which is plugged into the soil and gives us inputs about the moisture level of the soil. So basically the ends of the probe are used to detect the conduction activity of the soil. And before moving into how the values are obtained from the sensor, let's look at some prerequisites. We know that if excess water is there in a particular compound, then water when reacted with water gives ions, H3O plus, hydronium ion plus OH minus, and hydroxide ion. So more water produces more ions, and hence the mobility of these ions will increase in the soil. So we can say that more water produces more ions. So more water produces more ions, and hence our moisture level is more when there are more ions. That's the conclusion we can make. As I have written here, more moisture level gives rise to more ions, and this more ions leads to less resistance of flow of charge, because more ions lead to lesser resistance. So this reduces the amount of current. So the soil moisture sensor which I have given here basically acts as a voltage divider. As I have drawn here in the diagram, our soil moisture sensor acts as a voltage divider. What the voltage divider does is that it produces an output which is equal to Vn into R2 by R1 plus R2, which are these two resistances. Here R2 is nothing but the soil resistance. So as we have looked in here, that more ions produce lesser resistance. So here we can tell that more as the resistance increases, the output value increases. Now if there's more resistance, that means that there are lesser ions. So if there are lesser ions, that means that moisture is less. So at last we can conclude that the value given by the moisture sensor, if it is high, then it means that there is lesser moisture in our soil. And if the value given out by the soil moisture sensor is low, then it means that there is more moisture in our soil. Now moving on, this is the basic outline of how I created my program using the Arduino app in my laptop. So basically the major brain of my project is basically nothing but this Arduino Uno, which is connected to these components: a sensor and water pump, an ESP8266, and my ThinkSpeak account. And the data is transferred to the ThinkSpeak account using the ESP8266. Now I have created functions for all these three in my program, so that the input data can be transferred to my ThinkSpeak account, and there is no necessity to look into the serial monitor while monitoring my inputs. So this is the basic structure of my project. Now moving on to the program which I have used. So this is basically the program which I have used in my Arduino Uno. This program was clearly explained. So here you can see that these are the initialization statements in my void setup. These are my loop statements which I want to loop and repeat them one by one after another, so that my program can function. And this is the detailed program which I have written and burned into my Arduino Uno. I'd like to tell you that I have already burnt a program into my Arduino Uno, and the functioning of this project I will show it to you now.
Now, moving on to the project, this is the entire setup I'm going to use, and this is the plant which I'm going to water. And the water is, I'm going to fill up the water in this cup, and the pump is going to pump the water from this cup onto this plant using the moisture sensor data and the pump. So moving on, let me explain you all the components which are used. This is basically my Arduino board, which I have connected to the soil moisture sensor at pin A0, and in the program I also initialized this pin as an output pin, as it gives output data to our monitor. And this is basically the motor driver and the water pump, which I have connected to pin number 8 and a common ground. Basically what it does is that it inputs our data, because we want to control the pump on our needs. So I've set pin number 8, to which this motor driver is connected to as an input pin, because we want to control the pump. And this is my ESP8266 module, which I connected to pin number 3 and 4, and I have given these pins as a serial mode pins, so that we can retrieve or give information using the AT commands or the haze commands. So this is basically my entire experimental setup. Once I burn my program onto my Arduino board, I'm going to connect my Arduino board to an external supply using this battery connector. Using this battery connector, I'll just plug it in with this battery so that it works on its own. and to make the entire setup more compact. I'm not going to use wooden chassis. I'm going to use a box in which I'm going to put this entire experimental setup and put it close to the plant and show you how the water is being pumped. As you can see that I put my entire setup in a black box so that the setup becomes more compactable. And now I'm just burning my program onto my Arduino board using this program. You can see that the sensor readings are being taken from the serial monitor, and the same can be also seen from my ThinkSpeak account, which I'm going to show you now. This is my ThinkSpeak account, which receives real-time data using the functions which I have set up in our program. And namely, we have set up functions like send AT in our program, which usually pumps in data to our ThinkSpeak account so that we can get a real-time analysis of our soil moisture content and the pump status. As you can see that our pump is pumping in water because our threshold has been reached and the soil moisture content is less than our given threshold, so the pump pumps in data. And the same thing can also be reflected in our ThinkSpeak account. Also, the same thing can also be seen on my Virtuino app. You can just see the same thing on my Virtuino app, and I also set the alarm for when the moisture content is below a threshold. You can also see that the alarm also is set and the alarm is also ringing, and also the real-time analysis graph is also being plotted using my ThinkSpeak account, which I have connected to my Virtuino app on my mobile. I hope you liked my video, and just tell me how it is. Thank you.